Okay, now a standing wave is represented by the following expression. Okay, y equal to 15 cos 0.5 pi x sine 5 pi t, where y and x are in centimeters and t is in seconds. Determine the three smallest value of x, but x must be more than 0, that corresponds to the nodes and antinodes. Later on, find the amplitude at different x position. Good. So this is a standing wave. Okay. This is the standing wave equation, right? So this is the formula given. Let us relate this formula with the general formula for standing wave. So I want to rewrite this formula. Okay, y equal to 15 cosine 0.5 pi x and then sine 5 pi t. Okay, so what's the general formula for standing wave? General formula for standing wave is this one. Okay, y total equal to 2a cos kx sine omega t. Okay, and this a is actually amplitude of individual progressive wave. 2a is the maximum amplitude, for the standing wave, but a alone is the amplitude for the individual wave forming the standing wave. Okay, so so I want to rewrite this formula to compare with the formula given. Okay, this is actually the total y total. Y total equal to 2a, 2a cos kx and then sine omega t. Okay, put some bracket there, put a bracket there. Okay, so now you can compare. Yeah, the 15 is the maximum amplitude of the standing wave, and then you can see here the k is 0.5 pi. Yeah, because x compare with x, t compare with t, so the k will be this one, 0.5 pi, whereas the omega is the 5 pi. Okay, so this is how you relate. This is how you relate them. Then you can know. Yeah? The next thing is find out the unit. You see here, the unit given is centimeter and second. Okay, so from here we can see the displacement y and the x position, both of them unit centimeter. Whereas the time is in second. Okay, so both y and x are in centimeter. So what can we know about this? What can we say about this? The y and x both in centimeter, so you just write here the y here is in centimeter, x also in centimeter, and then the time is in second. The time here is in second. So what can we say more about this? Okay, first thing is the displacement y is centimeter, so the amplitude also will be centimeter. 2a also be centimeter. Okay, and then another thing is the x position is centimeter. So we can say the k is per centimeter. The k is in per centimeter. So later on when you get the wavelength, later on this k, you will get the wavelength. The wavelength also in centimeter. Understand or not? Because the k is per centimeter, So the lambda inside the k wave number will also be centimeter. This is how you know the unit. And then the time here is in seconds, so we can say the 5 pi is per second. So when per second, we know that omega can help us to find the period, isn't it? Period, since the omega is per second, so the period will get second. This is how we know the unit. Okay, good. Now another thing to note that is this part. I want you to know this one. Okay, I want to show you. Yeah, here, this one, this part. Okay. Oops, it's too big. Yeah. Make it smaller. Yeah. All right. Yeah. Why I'm drawing this part? This is actually called the amplitude formula. This is the amplitude formula. Okay, this is the amplitude formula. Another word is different value of x. Different x will have different amplitude. Different amplitude. Okay. So this whole thing is actually the amplitude. This whole thing is actually the amplitude. This whole thing is actually the amplitude. So this whole thing amplitude. Okay. This I just want to write again. This whole thing is actually the amplitude. Oh. And the amplitude value is different by x. Different x will have different amplitude. Different position will have different amplitude. Different particle has different amplitude. Okay? This is the first the thing you must know. Now, he asked for the position x. Which three smallest position of x will have the nodes? And also, what are the three smallest position of x as the antinodes? So how we will know about this? And this one, so we know this part, this is the amplitude. Okay, to find out the nodes and antinodes, so we use the amplitude formula. Okay, and we know nodes. Okay, for node, the amplitude is equal to 0. For antinode, the amplitude is equal to the maximum amplitude 2a. So and then from here we can find the x. Okay, so let us do it. Remember, you must modulus it. You must modulus the amplitude, so that you will later on you remove the when you remove the modulus, you will get positive negative value. Okay, this is important. Okay, so let's do it. Yeah, use this part. Node is amplitude 0, antinode is amplitude equal to 2a. Okay, so let us begin with a1. Okay, I want to find position of nodes. Okay, so for nodes, we know that the amplitude, the amplitude formula, amplitude is equal to 0. Okay, for nodes, amplitude is 0. Okay, so the amplitude formula is 15. This one, just rewrite that. Yeah, so it is 15 cosine 0.5 pi x modulus equal to 0. So from here we can find the x. Remove the modulus. Remove the modulus. So we know that remove the modulus. You will get positive, negative, 0? Do you have positive, negative, 0? No. Since it is 0, then just 0. Okay? Since it's 0, just 0. There's no positive, negative. Okay? Now, okay. So 15 cos this one, kx, or we can say equal to 0 also. So 0 divided by 15, you get 0. So now anti-cos. So this one pi x. So this one become anti-cosine the 0. Remember use radian. Remember use your this one must be radian. Why? Because you have this. Okay? Because you have this. You have this pi. You see that? Pi is in radian. Pi is in radian. So this one, your calculator need to set radian, not degree. Yeah, cannot degree. Okay. So next, anti-cos the 0. What do you get? Normally anti-cos the 0. Anti-cos the 0. What do you get? You get 90 degree, isn't it? You get 90 degree. So this one normally you will get 90 degree, but we don't want degree, isn't it? Because we want the answer in radian. We want the answer in radian. Because remember the graph. If you forget, you just remember the graph. Remember the graph. So about the theta, and this is the cosine theta, right? Cosine theta. So how is the graph of cosine looks like? It looks like this, isn't it? It looks like this. Yeah, it's yeah, smiling face. Yeah, you start from 1, then go to 0, then go to negative 1, then go back to 0 and go back to 1. So when do you have 0? When do you have 0? It's at here, this position. Okay, so it's between the 90 degree and 270 degree. Okay. Cosine graph, it is cosine theta is equal to 0 at 90 degree and 180 at 270 degree. So it's 90 degree and 270. So make it into radian. So how to write in radian? Don't write degree, must write radian. So in radian, and then of course you must relate to okay, this is here is this one. So anti-cosine 0, you will get 90 degree. 90 degree in the form of pi is pi divided by 2. Isn't it? Because pi is 180 degree. Pi is actually equivalent to 180 degree. Pi is actually equivalent to 180 degree. So 90 degree is 180 divided by 2, or pi divided by 2. Okay. Next, because we want 3 values of x, so you need to have 3 values here. Okay. So 90 degree is pi over 2. So okay. So and we know that this is 3 times the 90 degree, isn't it? This is 270 degree is 3 times yeah, right here lah. I just want to so this is 90 degree and this is 270 lah. Okay, this is what it means. Okay, so 270 is 3 times 90 degree, right? 3 times 90 degree. So this one is 90 degree. Pi over 2 is 90 degree. So times 3 lah. Times 3, then we get 270. So which is equal to 3 pi over 2. This is actually 270 degree. 270 degree. Okay. So from here we can know this is pi over 2. This one is 3 pi over 2. So what's the next one? Because we want to have three smallest value. We want to have the three smallest value. So you only have 2. So what you can do is look at the pattern. This pattern is 1, and then you have 3. The next one should be 5. Odd number. It should be odd number. It should be 5 pi over 2. That means the next one should be what I can say, the next one should be you will have times 5. 90 times 5 is 450. 450 degree. You try and multiply, or you can just apply cosine 450 degree. You will get 0. Okay, cosine 450 degree, you surely get 0. Okay. So if 1, 3, the next one must be 5. So we got already. So now we can solve it. We can find the x. So we can cancel the pi. Okay. Cancel the pi, divide by pi, and then find the x. Find the x. So what is the x value? Okay. So 1 over 2 divided by 0.5. 1 over 2, and then divide by 0.5. So you get x equal to 1. What's the unit? What's the unit? See that? So just now your x unit given in y and x are in centimeter. Your x is in centimeter. Your x is in centimeter. So don't put meter. You must put centimeter. This is in centimeter, not meter. Follow the unit given. Is in centimeter. Okay, centimeter. And then next is this one. This is okay, 3 over 2. 3 over 2 divided by 0.5. What do you get? 3 over 2 divided by 0.5. You get 3 cm. Yeah, is unit cm. So what's the next one? What's the next one? 5 over 2 divided by 0.5. So what's the answer? 5. I get 5 centimeter. See that? So 135. Is it correct? The answer? Yes, it's correct. The answer is correct. Okay? So this is the nodes. This is where the nodes is. This is the position of the nodes. The position where you can find 0 amplitude. You can find 0 amplitude. That means the particle at this position do not vibrate at all. Do not vibrate at all. That's why the amplitude is 0 all the time. This position is called node. They are called node. N-O-D-E, node. Okay? So that's correct. 135 cm. That's the answer. That's the answer. Now, find the antinode. So the same thing. Yeah? Same thing, but the amplitude now is 2a. Let's do the same process again. So find the antinodes. Find the antinodes. This time, our antinode has the amplitude 2a, maximum amplitude 2a, 2 amplitude. So it is amplitude. Our amplitude formula is equal to 2a. 2a. However, our 2a is 15 is 15. Okay, so you can straight away actually just write 15. Our 2a is actually the 15. The individual a is 7.5 cm. Okay, and 2a will get 15 cm. Okay, 2a is 15 cm. That's the maximum amplitude for the stationary wave. This is for the progressive wave. Progressive wave is only 7.5 cm. Times 2, you get 15. Isn't it? Yeah, that's correct. Okay, however, our antinodes has the amplitude 15 centimeter. You must write the unit there, centimeter. Amplitude 15 centimeter. So now you need to remove the modulus. Never mind, just write down the formula first, the amplitude formula. Write it down. Okay, write it down. So it is 15 cosine. Okay, this is modulus. 15 cosine 0.5 pi x. And then equal to 15 centimeter. So now anti-modulus, remove the modulus. Remove the modulus. This one you will get positive negative 15. Remember to write the positive negatives sign. Yeah, remember to write the positive negative sign. Positive negative 15 because you already removed the modulus. Okay, then this one can be cut off. The 15 and the 15 can be cut off. So what do we get? Okay, once cut off, it is equal, this cosine 0.5 pi x will be equal to positive negative 1. Positive negative 1. So now anti-cosine. Okay, anti-cosine. This one, the positive negative 1. Okay, that means you have anti-cosine positive 1 and also anti-cosine negative 1. So what do you get? You must have 3 values of this, because the x must have 3 smallest value. So anti-cos the positive 1 or anti-cos the negative 1, what do you get? Remember also there must be what? Radian. This one you must set your calculator in radian. So now look at the graph. Which position you can get positive 1 and negative 1? Let's redraw the diagram. Yeah, redraw the graph. Redraw the graph. Redraw the graph. Okay. Make it bigger. Cosine theta. Okay, so now cosine graph is actually start from maximum and then go to that. Yeah, so like that. I like to plot first. Plot and plot and plot. I like plotting more systematic. Plot first before you draw. This is cosine graph. Understand or not? Cosine graph. This is equal to 1, 0, negative 1. Okay. So now this is cosine graph. When do you have positive 1 and negative 1? Where is it? It's over here. Is over here. Positive 1 here, positive 1 here, and negative 1 here. So what is the value? What is the value here? 0 degree. Here is 180. This is 360, isn't it? So these are the first 3 position. We got already because he want 3 position of x. We got the first 3 position, 0 degree, 180, and 360. So we have we have this one, we have 0 degree, we have 180, and then we have 360. And we know that pi is 180. Okay, 1 pi is 180. So what do you have? 0 degree is 0 also, 0 radian. Yeah, 0 radian. Now you change to radian. So 180 is pi radian. It's pi radian, isn't it? Pi is 180. And then 360 is 2 pi. It's 2 pi. So these are the 3 positions. Okay. So now you can substitute into here. First you have 0 radian, and then you have pi radian, and then you have 2 pi radian. So for cosine 0, you get positive 1. Cosine pi, you get negative 1. Cosine 2 pi, you get 1. Understand? Cosine 0 and cosine 2 pi, you get 1. Cosine pi, you get negative 1. And this is how we got it. We got the 3 value. Yeah, 3 position of x. So now you can find the x. You can find the x because we can find the x. Yeah. So yeah. So the first one is 0. X also 0. And then the second one is pi divided by 0.5 pi. Pi divided by 0.5 pi. Okay. So what do you get? You get 2. Write the unit first. X is what's the unit of x? X is centimeter from just now. X is centimeter. Okay. And then pi is 2. Unit is centimeter. Okay. The next is 2 pi. 2 pi. 2 pi. Then you get 4. This is 4 centimeter. So at these 3 positions, you can get antinode. You can get antinodes. Yeah, at these 3 positions. These 3 positions, they vibrate at maximum amplitude 2A. Okay, 2A, because they are antinodes. So is the answer correct? What's the 3? Oh, 3 smallest value, but the x must be more than 0. So the 0 is not accepted because the x must more than 0. Look at the questions. He don't want the 0. X must be more than 0. So the 0 is not counted. So you must find another one because we need to have at least 3. So you only have 2. X cannot be. Okay. So what will be the next pattern? Look at here. What is the next pattern? Just now from 1 you get 3. So 1, 3. Next must be 5, isn't it? Odd number. So for this one, 2 and then 4. This is even number. What's the next? Guess what's the next one? Next one must be 6. Must be 6. Even number. The gap must also be the same. So this is the next one. 2, 4. Then must be 6. The next one should be 8 cm, 8, 10, and so on. Okay. So like for this one, 1, 3, 5. The next one should be 7. Like that lah. Yeah. This is how you guess. So is the answer correct? Yes. For antinodes, it occur at this position. 246 cm. 246. 246 centimeter. 246 centimeter. Okay, next. Look at the next questions. And remember the x must be more than 0. So this one cannot. So now, what's the amplitude? What's the, Okay, so now you can know 90 and 270 can get you can get 0 0 value, but at 0 degree, 180 and 360 you get 1 or negative 1. That is cosine equation. Okay, now I want to get the amplitude of a particle at this position. So how? This one very easy. You just substitute this x into the amplitude formula, 2a cos kx. You just substitute into the x value into here, and then you can get the answer already for each one. Okay, so let's do it. Let's do it. So let's do the question B. So let's do the question B. So let's start with the first one. Okay, where x is equal to 0.5 centimeter. Be careful with the unit centimeter. Okay, so we want to find amplitude. We want to find amplitude of that particle. You see, different particle, different position, we have different amplitude. Let's check out, is it different amplitude for different position? Find the amplitudes. So the amplitude is equal to what's the amplitude? Yeah, what's the amplitude? So the amplitude is 2a cos kx, or we can say 15 cosine 0.5 pi x. Write that down. 15 cosine 0.5 pi x. Then substitute your x value here. 0.5 centimeter. Oh, so be careful. Yeah, because your x is in centimeter. So your x is in centimeter. Okay, never mind. Just substitute your x there. Also your amplitude, your 15 also in centimeter, because your y is in centimeter. So your y is centimeter. Your amplitude here also must be centimeter. Okay. So this one should be set. The y should be the amplitude must be centimeter also. Okay. So now let's calculate. Okay, let's calculate. So what's the amplitude? Let's calculate. 0.5 pi times 0.5 and then cosine and then multiply 15. So the answer is 10.61. What's the unit? Follow the y, which is in centimeter. Centimeter, not meter. So be careful. Okay, is it correct for the first one? 10.61. Yes, it's correct. Yeah, it's in centimeter. Okay, 10.61 centimeter is correct. Okay, the first one is correct. So what's the next one? The next one, B. So number 2. So find out when x is equal to 1.1 centimeter. Again, is centimeter. So what's the amplitude? Just use the formula. 15 cosine 0.5 pi x. Okay. Substitute this one with what? 1.1 centimeter. The 15 here also is in centimeter. Now let's calculate. Okay, so the answer I got is negative. Oh, negative. Negative 2.35 and negative 2.35 centimeter. Okay. So you calculated this one you get negative 2.35 centimeter because 15 is in centimeter. Okay, the x is centimeter also, yeah, x in centimeter. So you just substitute x with centimeter. No need to change to meter. Don't need to change the x into meter because he's already said the x is in centimeter. So you remain the x, you substitute, when you substitute the x, remain in centimeter. Okay, so now look at the third one. Okay, the third one, when x is equal to 2.2 centimeter, 2.2 centimeter. So what's the amplitude? So similarly, just use the amplitude formula, which is 15 cosine 0.5 pi x. 0.5 pi x. So also substitute the x with 2.2 centimeter. No need to change to meter because x is in centimeter. Yeah, because the x is in centimeter. So you no need to change the x into meter. Okay. This one also the unit, the 15 is in centimeter. So you later get the amplitude is in centimeter. Okay, so calculate again. So 0.5 pi times x is 2.2. Okay, cosine answer and then multiply 15. So the answer is you will get the answer in negative 14.27 centimeter. Okay, centimeter because the 15 is in centimeter. Okay, is it correct? Is it correct? Yes, negative 14.27 centimeter. That's correct. The answer. Okay, so that's it for this part. Yeah, these questions. Thank you.